How many of you have used Kubernetes customer resource? In fact, the entire Istio API is building on top of Kubernetes customer resource. I believe what WebAssembly provides to Envoy is same as what Kubernetes customer resource provides to Kubernetes. My name is Lin Sun. I am the director of open source with solo.io. Prior to joining Solo, I worked at IBM for a very long time, and I have been contributing to the Istio project since the beginning of the project.
Hey everyone, I'm Shane O'Donnell. I'm the team lead here on the Gloo Mesh team at solo.io.
Today, we are so excited to talk to you about WebAssembly in Service Mesh and where we think WebAssembly in Service Mesh is headed. Let's talk about Wasm as a language. What do you think is the most popular Wasm languages? Probably not surprising. Rust is number one. And the desired language for Wasm continue to be Rust, and it's actually a huge increase from where it is today. I'd like to talk to you next about the progression of Wasm within the Istio project. Istio project in the very early days started with the mixer component, and we got a lot of complaints from our customer. The main reason is the mixer component is in the request flow. So if you are doing any policy enforcement, every single customer request needs to go through the mixer component. The Istio project really listens to what customer has, and Envoy filter was introduced to allow us as a project to extend our Istio proxy to add additional capabilities such as telemetry. As you can see, this is a screenshot from the most recent Istio. We're still using Envoy filter for telemetry purpose. Around the Istio 1.5, the project removed mixer components by using the Wasm runtime in Istio proxy. But there's one problem with that approach. Essentially, every time we need to make a change, we have to rebuild the Istio proxy related to the Wasm runtime. So not really ideal. The next thing in the Istio community is Solo starts to talk about a declarative model to allow user to declare their Wasm deployment resource in Service Mesh. And that was prior to me joining Solo. So it generated a lot of excitement in the community, which really laid a solid foundation to the WasmPlugin resource in Istio today. The WasmPlugin resource was introduced as an alpha resource in Istio 1.12. From a WasmPlugin resource, you as a user can define which workload you want the WasmPlugin resource to apply to. If you don't specify a selector, it's going to apply to all the workload within the scope of this particular customer resource. You can specify priorities, phases, plugin configuration for your Wasm binary. And most importantly, you can specify OCI image. The Solo team worked with the upstream team to support not only the standard OCI image, but also an OCI compatible image. What does compatible image means? It means you can wrap up the image, wrap up the Wasm binary in a Docker image. So how does the resource works? As a user, you come into your Kubernetes, you craft that WasmPlugin resource, and then you use kubectl commands to deploy that resource to your Kubernetes cluster. Istio-D, which is the control plane of Istio, is constantly monitoring customer resources that Istio care about, such as Wasm plugin resource. And it would translate that resource to a language that Istio proxy can understand and starts just pushing that configuration down to Istio proxy, then to the Envoy proxy. The Istio agent is also going to check whether that particular image already exists in the container. If it doesn't exist, it's going to fetch the image according to the image URL. It may be a OCI registry, or it may be a HTTP server. And then last but not least, it would push the configuration to the Istio proxy, which is using Envoy. Before I show you how the Wasm plugin resource works, I'd like to show you how you can do it with Envoy and Wasm binary. So in this folder, I have a code folder that contains a simple WebAssembly project I created using the Wasm tooling. It creates a simple assembly script project. And the only customization I have done is on the response header, I'm adding a header called Hello SoloCon 2022. I have built a Wasm binary ahead of the time, also using the Wasm tooling. So now what I want to do is, how do I run this with Envoy? I created a simple Docker compose file. Essentially, Envoy community provide Envoy dev images that I can easily run Envoy as Docker containers. And for this image, I'm exposing a 10,000 port, which is my listener port. And I'm mounting my Envoy configuration, which I'm going to show you in a second, as a volume, along with the Wasm binary from this code and the build directory. If you look at the Envoy configuration here, I expose the 0000. I expose on this particular port number, 10,000, which is what I expose in my Docker Compose. And in the filter chain, specifically for the HTTP connection manager filter, what I'm doing is I added a Wasm HTTP filter, and I specify a Wasm add header configuration to use the Wasm V8 runtime, along with this particular Wasm binary that I mounted to the Envoy container. So let's go ahead and run this. To do that, what I'm going to do first is using Docker Compose. So specify the compose file we just reviewed together and up command. So that allows me to run the Envoy container, right? And let's see if when I hit the 10,000 port, let's see if my Wasm plugin gets executed. To do that, I'm going to go ahead and cur localhost. Remember, we exposed it on localhost. And let's see. Hello, SoloCon 2022. So this is how you execute a Wasm binary inside of Envoy. Not so easy, right? Because the Envoy configuration, it's pretty hard, honestly. So let's see how to do that with Istio. Under the Istio folder, I created a Wasm plugin customer resource. In this resource, I give a name and I'm deployed to the default namespace. I'm also specify to apply this Wasm plugin resource only to the HTTP Bing app. And, I'm specifying my WebAssembly Hub and my Hello SoloCon image, which is the image build using the same binary that we run through our Envoy proxy earlier. And the plugin name is add header. So let's see how this works with Istio. In my Kubernetes cluster, I have HTTP bin and sleep already deployed in the default namespace. They already have a sidecar proxy running with the app container. What I'm doing next is I want to see if I have any WasmPlugin resources in my Istio environment, which I don't. And let's go ahead, deploy this WasmPlugin resource we just reviewed together. As you can see, it's just applied. So now if we do WasmPlugin resource, we should be able to see Hello SoloCon, right? So if we do a name of Hello SoloCon, we will be able to see the contents right here. So this is exactly the same as all the other Istio resources. Pretty easy to use, right? So let's see if this thing actually works, right? So the next thing we're going to do is, remember we have sleep and HTTP bin. So from the sleep pod, we're going to call the HTTP bin and, see if the response header have Hello SoloCon added. Yay, it is added. Excellent. So let's see how this works. If we go to the Istio D pod, we would see some information around our Wasm plugin, hopefully. So if we go to here, you can see the Wasm plugin configuration is being pushed. Remember we talked about that, right? From control plane push to Istio proxy. Through the Istio agent, and also there's an extension config discovery service that pushes the configuration, the extension config to HTTP bin. Let's see how the logs works on the HTTP bin side. So you can see our Wasm was executed, right? And the context was written successfully. If you go to the HTTP bin container, and if you check the was/leap/istio data, you can see this Wasm binary was downloaded. Remember in the diagram, we talked about the Istio agent would check if the image is local. If it's not local, it's going to go to the OCI registry to try to download that, right? So that's interesting. So let's see if this is the right image, because remember that OCI image we had, right? So this is our OCI image. So what we're going to do next is to kind of pull the image using the WasmPlugin tooling. So what this is going to pull the image from the WebAssembly Hub, the SHA does match, right? So that's exactly the same image we ask Istio to use, and magically this image showed up in our Istio proxy container, and Envoy was smart to pick it up and use it, right? So that's way more easier than using the Envoy configuration yourself and figure out how to run it yourself. One last thing I want to show you is looking at the dashboard of the Envoy configuration, right? So this is the magic of Istio. You don't have to kind of create this yourself. One thing I want you to do is if you search for like the Wasm binary, you're actually not going to find it. Well, that's too much matches. But what's interesting here I want to show is if we search for Hello SoloCon, Remember we had the HTTP filter in our Envoy configuration, right? So this is under HTTP connection manager, right? So this is exactly what you config manually without Istio, right? So Istio configs all this automatically for you. One thing I would highlight here is, right, the config discovery. It's interesting, right? The data, the ADS data is empty, right? Because Envoy support extension config discovery service. So that allows the control plane to push extension configuration from the control plane to the proxy dynamically at runtime. And this initial fetch timeout really says, I'm not going to timeout until that configuration is in place before I execute. So folks, that is your Wasm plugin resource. It's just so much easier than doing it on your own with Envoy. With that, I'm going to pass it over to Shane to talk about Wasm in Solo's product.
So let's talk about the current state of WebAssembly. Where are we at today? What can you do with WebAssembly? What should you do? And maybe let's talk about some things that you shouldn't do with WebAssembly, because it's important to understand some of the limitations. So let's kick right off with that. First, the good stuff. WebAssembly is really good when you just want to make some quick changes and you don't want to do any redeployments of your applications. We see this in a number of different situations. So for example, you might have a legacy application where the deployment process is complex or maybe even no longer documented, or the folks who maintained it are gone. And for various reasons, we need to make behavior changes, but maybe we're too afraid to do the deployment, or maybe we just don't have a best-in-class CI/CD pipeline. And even if we know we need to bump a dependency to fix something like a CVE, maybe the turnaround time just isn't acceptable, especially if it's a high severity thing. If you've got something that could potentially cause remote code execution in your environment and you're looking at a multi-day turnaround time, that might not be acceptable. So WebAssembly can be a good patch to mitigate those kinds of things in the short term until you can get a more longer term fix in place. It's really good for processing small amounts of data. And the emphasis here is on small, because remember, all of the data that we process, whether it's headers or maybe even the full body of a request or a response message, anything we're handling in a WebAssembly filter needs to cross that virtual machine boundary. And there is a little bit of a performance hit when we do that. The last thing that I really like using WebAssembly filters for is if you want to start emitting custom metrics based on, again, small amounts of data. Specifically, if it's something like headers, we found it's a really good use case. And like I mentioned earlier, I do think it's important to take a step back and think of some of the things that WebAssembly isn't as good at. And Envoy's already good at a lot of things. Out of the box, you get some really good features, and various different vendors, including Solo, have built in native filters into Envoy that let you do things like enterprise grade auth, rate limiting, large transformations, things like XSLT and inject transformations. And all of these things have been battle tested in production. We know they work. They're well documented. They've been used by thousands of users across millions and millions of requests. So let's just make sure we're not reinventing the wheel with these WebAssembly filters. One of the most powerful things about WebAssembly is that it can do almost anything an Envoy filter can do natively, or anything a native Envoy filter can do. But the problem is, because it can do almost anything a native Envoy filter can do, there's a really strong temptation once you've figured out and you've gotten good at WebAssembly to use it to do anything a native Envoy filter can do. But really, we need to kind of show a little bit of constraint, and anything that already works, we shouldn't be reinventing and doing again with WebAssembly. So how do WebAssembly filters work in Gloo Mesh? Typically, you'll have a setup like this, and this is just 3 clusters, but you can imagine that this scaling to dozens or hundreds of clusters. We'll typically have a management plane that has a management server that kind of is the brains of the whole Gloo Mesh program. And when it runs its transformation loop, it'll figure out which resources need to go where and start distributing all of the configuration to all of the clusters in your mesh. So each cluster in your mesh is going to be running the Gloo Mesh agent, which will pull in all of these configuration changes and then propagate them out to your Istio control planes that are running in each mesh. You might also have some other things that maybe don't have sidecars like services, but that are still ultimately Envoy proxies. So the prime example that you might think of here is the ingress gateway. Because it's ultimately still just Envoy at the end of the day, it's also a valid target to start shipping WebAssembly filters to. So what this looks like in the Gloo Mesh use case is you'd write a WebAssembly piece of configuration, the management server will pick it up, and then if you'll excuse my crazy arrows drawing, this can get propagated out to every single cluster in your mesh, be it for sidecars or for your gateways. So as you can see, this is really powerful because you can basically get away with writing a few lines of YAML in one server, and then you get all of the benefits that come from these WebAssembly filters pushed across all of the clusters and all of the meshes, and if you want, all of the services across your entire global service mesh. So it's really, really powerful. So now I want to jump into a demo and just show you two quick use cases that I think are kind of good use cases and good examples that show off some of the things that WebAssembly can do today. So this first use case I have in mind is an interesting one. So for those of you who aren't familiar, this is the Istio book info application, or it's a slightly modified version of it, actually, to be specific, but it's basically an application that kind of ties together a bunch of different microservices. And the scenario that we're playing out here is, you can imagine we've got maybe a very overzealous product owner who saw all of the tables in our database and said, hey, some of these things, it would be really cool if we could show these on the front end to the users. So maybe let's just dump everything we got out there. And so we've added this new field that's not typically in book info called word count, which is great because, yay, it's a new feature, more stats, users love it. But if you'll notice, well, we've also accidentally exposed the author's social security number. So poor William Shakespeare's social security number here has been exposed. And this may seem like a little bit of a far-fetched scenario, but something very similar to this was in the news recently, where a bunch of school teachers' social security numbers got exposed in plain HTML on a public-facing website. So this kind of stuff really does happen. And again, that you could be in one of those situations where redeploying this app or rolling back isn't an option, or isn't an option in a timely manner for a variety of reasons. So let's look at some of the things we might be able to do to mitigate this. So I'm opening up a console here, and I know we showed that 3-cluster multi-cluster environment before, but just to keep this demo a little simple, I'm going to keep this one to a single cluster that's running double duty, both as the Gloo Mesh management cluster as well as the agent. So you'll see here we've got our enterprise networking pod running here. That's the brains of the operation, as well as the enterprise agent that's running, that's going to handle writing everything that Istio needs to take care of. So what I'm going to do is I'm going to apply a filter that I created earlier. So I'm just going to do a kubectl apply here. And what this filter is a data loss prevention social security number filter. And this is a filter I created. I actually have the source here. Well, just go to the source real quick. And as you can see, it's really quick. It's under 75 lines of code, and most of that's boilerplate as I scroll through this. But all it really does is it's going to parse through the body of the response. So all of the information coming out of your servers, it's going to run this regular expression that detects if there's a social security number, and it's just going to replace it with a bunch of stars and asterisks so that that information never leaves your cloud, never leaves your mesh, and definitely never gets to the point of being exposed to the general public, which is really important, especially for PII and especially for something like a social security number. So if we go back to our browser, I'm just going to refresh this page here. You can see our social security number has been updated to be all stars or asterisks instead of the original social security number. So we haven't made any changes to our application. We haven't done a redeploy. We haven't even done a restart. And we've gotten this, more secure functionality that's prevented something, or at least mitigated something that could have been a really, really big deal, especially if the original application team wasn't able to roll out a fix for this for like a few days. And this is really where the power of WebAssembly kind of shines. One other scenario I'd like to get into, so that was scenario one. Scenario two, another part of our new and improved book info service is if we look at our review service, we've actually made some changes here. Typically, this review service, as anyone who's familiar with it knows, is a read-only, so you can pull reviews from it, but we've actually added a post URL, so you can actually post new reviews to this service. So I'm just going to do a curl here to kind of show what I'm talking about. So I'm curling and I'm passing it a user ID just as an arbitrary header with a value of Shane. I'm giving it the post has a body called test review, and I'm posting it to localhost port /reviews. And what this is doing is this is hitting a ingress gateway that I've set up in this cluster. The ingress is set up to route requests that go to /reviews to the review service. And ultimately, it's going to hit that review surface, obviously via the Istio or the Envoy sidecar. And ultimately, in this service up here, you can see in the logs, if I send a few more curls, you'll see each time it logs out, received a request from a new user, Shane. So that's interesting. But if you're kind of putting on a black hat or an attacker's security mindset here, you're saying, hey, thanks for your review, Shane. That's the string I provided. I wonder, is that something we can exploit? And as you can see here, they are logging it out. And if the word log isn't setting off any alarm bells for you yet, it's probably worth mentioning that the review service is a Java application. And as a Java application, there's a pretty good chance it's using log4j and could be vulnerable to a really big vulnerability that came out recently, made headlines everywhere. But basically, it goes like this. If you're using the log4j logging library in Java and a particular string gets logged, there's a vulnerability where it'll accidentally dial or unintentionally dial an external address, which is essentially a way to enable you to run a remote code execution on anyone who's using this. So it's an incredibly high threat. And I think it was like a 10 out of 10 or very close to it. It allows anyone with very low effort to do a lot of damage. So here's an example of exactly what you don't want to happening here. So I'm going to copy paste the same curl, except instead of Shane, I'm going to say that my username is actually a Jindy string that connects to an LDAP server that's on an evil server. And other than that, the request is completely the same. So once I make this request, thanks for review, this is awful. And you can see it gets logged out here, which is thankfully this particular instance, I made sure we don't actually use log4j in this, but just as an example, you can imagine it does. And this is really bad, right? Because again, what if this can't be patched? There's a bunch of different things you might have to worry about here. Now, thankfully, we've created a filter that mitigates against this exact thing. So I'm just going to apply that filter and show you the source for that again, because I think the other kind of recurring theme you'll see here with these WebAssembly filters is they're actually pretty straightforward in terms of source code, in terms of the size of the source code. You can see here we're under 50 lines total, including boilerplate. And there's a bunch of different log lines at various debug and info levels, but ultimately it's very similar to the previous one we looked at, where we've just setting up a regex that looks for a Jindy string. And you can make this a lot more complicated. This is just a basic one. It's probably not even going to look for the full exploit string, but just as an example, we're looking for anything that has that Jindy with the curly braces in it. And if we detect it, not only are we going to log it, we're going to reject the request with a 403 forbidden, and we're also going to increment a custom metric. So at the top of this file here, you can see we're defining a custom metric called log4j CVE attempts, and I'll dive into that in a second. But going back to kind of our terminal here to try this, now that this filter has been applied, if I send a request, now instead of success, you're seeing request rejected due to invalid attempts. And if I send that a few more times, you see it still says all of that. And it's also important to notice that, we can still send our good request. If I go up to the one that had Shane in it, we still get a success and we're still seeing log lines. But if I send the bad one again, you see it's not getting logged. So we've basically mitigated this because, again, this filter is running at the sidecar, so it never gets to the Java service. So we don't have to worry about log4j and that vulnerability anymore because we've caught it, we've intercepted it before it's even reached the application that has the vulnerability. And I did mention that we had metrics as well. So this is the Prometheus stats of the sidecar. So for anyone who's familiar with the Envoy stats page, this is just that. I've got a port forwarded locally to 15,000 here. But essentially, I've logged out a log4j CVE, I think I called it CVE attempts. And here you see here, we've got 4 attempts. And if I just go send another one real quick, refresh this page, you can see it's gone up to 5. So this is a metric that's, in Prometheus format, which means you can, point a Grafana at this, you can alert on it, you could send Slack notifications, emails, whatever your alerting system is. And as soon as someone starts hammering you with this, you can have your security team notified immediately and make sure that, you're not in too much trouble here. So super, super powerful. Again, this was deployed in seconds, if not, minutes, the worst case scenario. The code was 50 lines of code, and we've mitigated against something that could be a really, really big deal if it was allowed to, sit for, I was going to say days, but honestly, even hours. If someone's, trying to hit you with this, could be really, really bad. So now I want to talk about WebAssembly Hub. And WebAssembly Hub is a tool that Solo has put out there, and it kind of pairs really well with a CLI tool that we released called Wasm, which really gives developers best-in-class tooling, which they can use in order to build and publish, as well as discover and deploy WASM filters, but specifically WASM filters that are wrapped in OCI images. So OCI layers are the same kind of technology that Docker uses to make Docker images. We're doing something similar here. It makes it really easy to ship around the actual filter bytecode, as well as a bunch of configuration that kind of lets the host know what version it's running and what kind of config it should accept, that kind of stuff. And this is something that we're really proud of at Solo, and the community has really embraced it. We see so many filters that are pushed up here. Do I have a tab open here that we can look at? So, for example, these are all the filters that are just published under my account. You can see the DLP one here, or from our first demo. You can see it's published here. You can see it's been used 179 times. We've practiced this demo more than once, I can tell you that. But again, you can kind of look, it's all in the same kind of idea of not reinventing the wheel. You can see what other folks have published up there, as well as actually getting this stuff into an ultimate Envoy sidecar is actually quite challenging. So it's really good to have that powerful capability and make it as simple as using a Docker image. That's really what we were going for here. So now that we've talked about the kind of current state of WebAssembly, we wanted to talk real quick about the future of WebAssembly, and specifically with Solo in mind. And one of the big things that we talk about in the future, specifically around Gloo Mesh, is this idea of workspaces. We've kind of re-released Gloo Mesh as a Gloo Mesh 2.0 release, built around this core concept of workspaces. And ultimately, what it really is it's a really strong guarantee on multi-tenancy. So it lets you logically partition your configuration between pretty much any way you want, because all the workspaces at the end of the day it's a list of clusters and namespaces within those clusters. And you can use that to divide up your service mesh, whatever way makes sense for your organization. We've seen folks use this to give, for example, a workspace to a specific team or a workspace to a specific application, especially if it's an application that has a number of smaller microservices associated with it. We've also seen, or we anticipate folks to use this for things like infrastructure. So you can imagine a gateway might have its own workspace that maybe has more stricter security posture. It's a little bit more locked down than stuff that's deeper into your stack that isn't as publicly exposed. And some examples of what this might look like. So we've got here an example of 2 clusters. You can see, like I mentioned, you've got maybe gateways in its own cluster, and then the book info workspace has its own, it's spread across 2 clusters, but the book info application is still all contained in a single workspace. So that team is kind of abstracted away from the fact that they're working on 2 workspaces, but they still get all the benefits of kind of controlling things in one place if they want. And the other really strong part about workspaces, which specifically for WebAssembly is incredibly important, is that it encourages sharing not only services across teams, so you can export services that are reusable, things like notification services or things of that nature, but you can also share configuration. So in this context, you might have a security team that has all of these various different WebAssembly policies and WebAssembly filters. So like the 2 we just walked through with the DLP stuff, the log4j mitigation. I've also added in an auth metrics one and an IP block list here to this diagram, but you can imagine the security team writes all of these once, and then any other teams that says like, hey, I've got a Java application, I should probably pull down this log4j one just in case. And you can start using these throughout all of your clusters, throughout all of your workspaces, even though you've kind of only written them in one place by the team that's the expert in the technology. So really, really powerful stuff. We're really stoked and can't wait to see what folks do with it. So we want to talk about the future of WebAssembly at Solo. I just kind of talked a little bit about the multi-tenant workspaces, which is obviously a huge part of it. We want to get Gloo Mesh running at scales that we never imagined before, and we're already seeing customers pushing this to absolutely incredible scales. But in terms of WebAssembly, we're going to make sure that we definitely keep on supporting the latest versions of Istio, of Envoy. We want to make sure we've got the latest of everything running at any given time. And we are excited to announce today that WASM tool we talked about, that CLI tooling that's been so accepted and so welcomed and so used by the community, we are donating that to the CNCF. we just feel like it's really good to be working on this stuff in the open, and we'd like to welcome even more contributions and even more feedback on some of the designs, some of the work folks have done in the spec. It's just been tremendous progress. And in the same vein, we're also announcing that we're going to be donating WebAssemblyHub.io to the CNCF. So we've just seen so much usage here. It's been so valuable both to us and to the community. We wanted to be able to give it back, and we're really proud to be able to announce that today. So that's everything from the slides, but if you guys want to ask any questions, Lynn and I will be around for the next few minutes to ask questions live. Thank you.